Hello, welcome to homework 8.05, factoring the difference of perfect squares. Alright, so this is basically reverse double distribution. Instead of starting with kind of one of these, where we multiply them out, alright, we're starting with something simpler and turning it back into those double parenthesis setups. So the key to these is always thinking about sort of perfect squares. And it's basically saying, all right, x squared could really be what times what? And you're looking for something that's the same in both these parentheses. So x squared could really be x times x. 9 could really be 3 times 3. We're always looking for what we can put in these parentheses that are going to be exactly the same. So on one like this, the way this breaks down is we set up our double parentheses. This becomes x and x, just like we showed up here. And this is going to become 3 and 3, just like we showed up here. Now, because this is a negative 9, the only way to get a negative when you're multiplying is to have one be positive, one be negative. Doesn't matter which one you make positive, which one you make negative. I could have flipped these around, and it would have been exactly the same. All right, so on this one, again, we'd set up our double parentheses. X squared is just going to give us an x and an x. Now, if you're not sure like what the perfect square of 49 is, you can always just use your calculator, and you would just do second x squared to bring up the radical sign. That's our square root. You'd put in 49 and say, oh, the square root of 49 is 7, so this is x plus 7 and x minus 7. All right, on this one, we don't really have any numbers to worry about, so this one is just going to be b and b, and then this one is just going to be a plus a and a minus a. All right, if we look at number 4 here, again, r squared is just going to be r and r. Now the 144, again, if you don't know it, it's just second square root. 144 is going to be 12, so it's r plus 12, r minus 12. All right, so again, you're gonna once you get used to these, they're really not that bad. All right, so this is just going to be y and y. This is just going to be a plus 4 and a minus 4. All right. Number 6 here, again, is one where we just have letters, so those are almost easier because you don't even have to worry about figuring out like the numbers. Y squared is just y times y. X squared is just x times x, and again we need one positive and one negative. Alright, now if we look at number 7 looks a little different, but we kind of just break it down. Alright, first we say, alright, what's the perfect square of 121? Which again you can always just do on here, second x squared, which brings up the radical sign. 121 is 11. So that's 11 and 11, but we also have to worry about this p squared, so that's 11p and 11p. And then the square root of 1, or the perfect square of 1, is just plus 1 minus 1. All right, let's take a look at number 8. All right, so a common mistake with these is that kids always like to have the x or the letter in the front. But you kind of have to keep it in the order that they gave it to you. Like if you noticed, I put the x first, the x was first here. I put the x first, the x was first here. I put the b first, the b was first here. I put the r first, the r was first here. I put the y first, the y was first here. Okay, so let's take a look at this one again. So the 1 comes first, so that's what we need to put first, the 1 and the 1. And then on the back side, that's where the x squared is, so the square root of 25 is 5, and then the x squared is going to be 5x, and 5x. And again, because it's negative 25, one of those is going to be positive, one of those is going to be negative. So you got to keep the order that they give it to you. You can't just go and change the order. Alright, so let's take a look at the back here. Same sort of thing. Alright, they're just getting a little more involved, but the square root of 4 is 2. So these are going to be, and then x squared, so it's going to be 2x and 2x. The square root of 25 is 5, so that's going to be a plus 5 and a minus 5, but don't lose your y squared, so plus 5y minus 5y. Alright, number 10. Alright, main thing here is that you don't change the order. 121 comes first, so the perfect square there is 11, so the 11 has to come first, and then the x has to be in the back, so plus x minus x. Alright, let's see here, set up our double parentheses. 25p squared, well 25 is going to be 5 and 5, and then p squared is just going to be p and p. And then we have y squared, so that's going to be plus y and minus y. Again, number 12, just make sure you don't change that order. The square root of 64 is just going to be 8, and then y squared is going to be a plus y and a minus y. Okay. So let's take a look at these last four, because the last four are a little different. They say factor completely and check. All right, factor completely is basically code for factor twice. We're going to have to do 2 steps here. And that's basically, our first step is going to be to take out a GCF, and then our second step is going to be to do this perfect square stuff that we've been doing. So if we look at number 13 here, we need to take out our GCF. So the GCF of 3 and 12 is just going to be 3. Now, x cubed and x to the first, we have to take out the smaller one, so our GCF is going to be 3x to the first. So we're going to divide each of these by 3x to the first. 3x comes out front, and then we're left with 3 divided by 3 is 1. X cubed divided by x to the first is x squared, because we subtract the exponents. You could write 1x squared, but you don't really need to. And then 12 divided by 3, negative 12 divided by 3 is going to be the minus 4. The 1 minus 1 is 0, so those just cancel out. That's step 1. Step 2 now is to go forward and say, all right, x squared minus 4 can really be x, and then plus 2 minus 2. Okay? So let's try another one of these. 14. All right, the GCF of 4 and 400 is just going to be 4. This one we can't take out an x because only one of our terms has an x. So we're just going to take out a 4. We're going to put a 4 out front and get x squared minus 100. And then again, this can break down. So it's going to be 4x plus 10, x minus 10. And there's kind of a nice progression here. You start with no parentheses, you go down to 1 parenthesis, you go down to 2 parentheses. All right, so there's sort of a progression as you work through these. All right, number 15, 8x squared minus 2. Again, we're looking for the GCF of 8 and 2, which is just going to be 2. Again, we can't take out any letter because this term does not have an x. So we'll divide both of these by 2. We'll get 2 4x squared minus 1. That's step 1. And then this has to also break down. So we're going to end up with the square root of 4 is 2. So 2x and 2x. And then the square root of 1 is just 1. So plus 1 and minus 1. Now, one of the biggest mistakes we see on these problems is kids just forget to keep bringing this 2 down, and the 2 just sort of disappears, and then they lose a point. So you got to make sure that all of these pieces stay in place and they don't just kind of vanish. All right, last but not least, the GCF of 14 and 14 is just going to be 14. So we'll divide both of these by 14. 14 comes out front. we're left with m squared minus 1. Again, we're going to break that down one step further. So we're going to get an m plus 1, and we're going to get an m minus 1. All right? All right, that is it for today. I hope this was helpful, and have a nice afternoon.